Welcome back. Let us solve the problem number 6. This time, the reverse from the rectangular to cylindrical transformation. Okay, now let's start with problem 8. Problem 8. So the challenge here is you have the vector f, which is 10ax minus 8ay plus 6az. Now at point P, given 10, negative 8, and 6. Okay, now we can try to draw this one, transform this into cylindrical. So can actually create a drawing like that. So this is 10 for the x, and for the y, you can assume that this is the negative y, this is x, and then this is z. You can actually do that. So let's say so imagine this is your vector, then that's equivalent, the equivalent cylinders like this. Okay, so you have this center point there, and then you have that vector there. Okay, so the transformation is simply just a referencing, or I mean the how you express the vector. Okay, so that's but basically they are the same vector. So the vector f, we just want to express this into a cylindrical. Okay, now so if you look at the top view, okay, because it's difficult to visualize it in a 3D, let's take a look in the top view. So this is, let's say, your y, okay, and then this is your x. So given 10, you have 10 here, then you have negative 8 for your y. So this time I follow the convention, positive y is on the right side. This is your so we can visualize our cylinder. So this is actually the row, okay, and then your p is actually here. Okay, so that's your, this is your row, and then this is your p. Okay, so I write row here. So there are two ways to solve this. Okay, two ways to solve. First, row is, we know it's like the Cartesian Pythagorean theorem, no? So we can direct the x squared plus y squared. This is equivalent to square root of 10 squared plus negative 8 squared. Okay, so but this one is a bit challenging because this is not the proper way of doing this. So you might be tempted to do that, but the best way to do this is we express the f. Okay, we just need we need to get the f of rho, which is actually equal to the f multiplied by the a rho. Okay, so what is so f is actually in cylindrical, so like fc, this is fp a rho. Okay, so the magnitude, no, so this is that product, so that's that product. So then plus f p a p plus f z a z. Okay, now take note, fp, so f is equivalent to 10 ax dot a rho. So we just simply distribute this one, okay, to the all the coordinates x, y, z. So plus, sorry, minus 8 ay dot a rho plus 6 az dot a rho. Now ax dot a rho, okay, so ax dot a rho, this is your actually it's a challenge to this is the convention, right? Because I'm changing the drawing into something the most common visualization without knowing whether it's positive or negative. So this is the direction of your a rho, okay, and then actually the direction of the cylinder for the arrow, as you can see, it should be like that, no? It's a circle, but if you're at this point, actually it points this way. Okay, so this is the A and P. Okay, now for your arrow, okay, so this is actually with respect to your angle P there. So arrow is actually the cosine equivalent of AX. Okay, this is AX and then this is A. So I'm trying to plot the drawing for unit vectors. Okay, so take note of this. So now if you want to expand that one, this is actually the P. Okay, so AX dot arrow is cosine of P. Okay, cosine of P, because so the component AP, if you mirror it to AX, okay, so that becomes cosine P. Okay, or you can say cosine P is equal to the opposite, which is cosine P is adjacent, which is AX. Okay, sorry, I made a mistake there. So but this one, cosine P is like it's not it's the dot product, no? Dot product of AX and AP. So it's just like you transfer AP, magnitude AP to AX. So this, what is the component AP in terms of AX? So that's that might be the term. So this is 10 cosine of P. Okay, then minus AY with respect to AP. AP is so that's sine. Okay, 8 sine P. Then AZ that AP is 0. Okay, this is 0 because regardless of whatever the value of your rho, still the z's doesn't change, so it means there's no there's a rho and az are orthogonal, so that's why. Now the p here is not the p that is so the p here is the tangent of inverse negative 8 over 10. So this is from the point at point P. Okay, so this is equivalent to negative 8 over, so that's negative 38.65 degrees. Okay, so therefore FP is equal to 10 cosine of negative 38.65 minus 8 sine negative 38.65 degree. Okay, so the answer here for the FE is equal to 12.81. So this is for your value for your magnitude of your rho. Now let's find the magnitude of your P. So to find the magnitude of your P, you just multiply the vector F in rectangular form that the unit vector arrow. AP. So this is equivalent to 10 AX dot AP minus 8 A Y dot AP plus 6 AG dot AP. Okay, so here the AG dot AP is still 0. Sorry, this one not a arrow, this should be AP. Okay, Now your 10 ax dot ap, if you look at this here in the drawing, okay, if you look at this, actually it points to the negative of ax. So if you want to transfer that one, okay, so actually you can visualize this as like that, no? Sorry, it's like this, no? You have your ap here, ap, so that's your ap, then actually your ax is here, no? So given this vector, this is your vector, this is your angle p, okay. So this ap is actually to the opposite of, okay, so this is a v sine, okay, so I just write sorry, this actually, this value here l, that's actually ap sine p, okay. So this one is ap, no, not ap, not arrow, so that's ap, so this here is arrow sine p. So therefore our ax dot ap is actually equal to 10 negative of sine p. Why negative? Because you see the vector ap is pointing to the negative of x, and then if you want to convert ap to x, you actually use the sine law, sorry, not the sine law of the, but the sine function, okay. So to convert this one to the other side, so we know that sine is opposite over adjacent, so minus 8 ay ap. So if you look at here, so in terms of y, it goes to the positive, of ax, sorry, ay, but if you look at this here, so actually y is the adjacent, this is the y, right? So this is the y, so that's the adjacent of angle p, so that's, we use cosine, positive because it points to the direction of y-axis. So this is, okay, so you just substitute the value for your p, so this becomes 10 sine p. When you substitute the value, this is actually equal to 0. 10 times negative sine of 38.65 minus 8 times cosine 38.65. Okay, so this is actually equal to 0. So negative 38.65. So therefore, our final answer is, in terms of the cylindrical coordinates, we have 12.81, 0, and then 0. Okay, sorry, I should put like this to show that this is a vector. Okay, vector in cylindrical coordinates. I will use C to show that this is cylindrical. Okay, so this is our answer. Okay, now let's proceed to problem B. Problem B is quite similar to our to the previous problem. So you have G and then at point Q. And the challenge here is how you express, no? So we find first the value of your G along the or instead of G, maybe we can write 0 is equal to G times arrow. Okay, so we substitute this one in G dot arrow, so you have 2x plus y ax dot arrow minus y minus 4x ay dot arrow. Take note, there's no az present in the G. Okay, so now we know that ax dot arrow Okay, if you look at again this if you look at this drawing in the top view, so this is your A row, this is your AX, so AY, so therefore this is your P. Very simple. If you transfer A row to AX, this is you use the sign, so this is actually sign, sorry, cosine, adjacent. X is adjacent, so this is cosine of P, and the other one is sine because it's opposite of the P. So very simple. Now the P here is not the P that given it. So P here is the angle at P at P at point Q. Now we know at point Q, P is P. Okay, so here P is P. Okay, so therefore we can simply, but we know that X, okay, at point P, okay, sorry, at point Q, okay, at Q, so this is Q, X is equal to rho cosine of P. Okay, then also Y is equal to rho sine P. Take note of that. Why is it this case? Because we're given with the point in terms of the cylindricals. We need also to express that one cylindrical. So we have so therefore GP now becomes 2 times X. Okay, 2 times X, which is rho cosine of P. Okay, so you have 2 here, and then you have plus Y, which is rho sine P, times the cosine of P. Okay, so AX dot AP is cosine of P minus Y, so Y is rho sine P minus 4 rho cosine of P times the sine of P. The sine of P is the AY times AX. Okay, you just arrange this equation and then we will get the answer. So 2 rho cosine P times cosine P, you distribute and then cancel, so you will have the answer here is equal to 2 rho cosine rho squared, okay, plus minus rho sine squared P. Okay, and then this is it. When you multiply this sine P in the second term, this one becomes sine squared P, and then plus 5 rho sine P cosine P. Okay, so 5, we multiply rho sine P in the first term times cosine P minus 4, so it is plus 4 cosine, so this becomes 5. Okay, so this is our magnitude for the rho. Okay, so this is our magnitude for the rho, so you can write actually 0. Okay, now how about the magnitude for our P? The same step, so we multiply the vector, rectangular vector G by AP. Then so therefore this is equal to the same, 2x plus y, then ax dot AP, so we distribute, then minus y minus 4x ay dot AP. Okay, we should be careful with this, otherwise we might AX dot AP is what? So this is negative sign. Okay, careful, this is negative sign. So we replace also x and y, they are the same. That's the x and y at point Q. So that's 2 rho cosine P plus y, which is rho sine P, times AX minus AP is equivalent to negative sine P. Okay, minus y, which is rho sine P, minus 4x, which is 4 cosine P. Then AY dot AP, so that's adjacent to the AP is adjacent to y and going to positive direction, so this is positive cosine of P. Okay, you arrange this equation and then you will get the final answer. Okay, I leave that to you. So the final answer here is equivalent to so 4 sorry, you have negative sign, so this is 4 rho cosine squared P minus rho sine squared P, and then we have 2 plus 1, so this is minus 3p 3 rho sine P cosine P. Okay, this is very simple. You just work this previous equation and then you will get this answer. Okay, now so we don't have G because our vector G has no AZ, so therefore we have this vector, okay, G, but I will write the vector form because vector G rho, you can write it because it's very long, so I just write it this way. So okay, so that's it. That's the answer for problem B. How about problem C? Okay, now problem C is still the same, but it's in the opposite again, so rectangular to cylindrical. How to do this? Okay, so very simple. We wanted the rectangular component, so we're looking for AH with a vector HX, HY, and HG. So we're looking at these values. Okay, so HX, okay, is equal to the vector H in cylindrical. So since it's cylindrical, you dot product it with AX. Okay, so that product with AX, so therefore this is equal to 20 a rho dot AX, okay, and then minus 10 AP dot AX plus 3 AZ dot AX. Okay, so now a rho dot AX, what is it? This is cosine of P. Now what is P? The P here is at point P. Okay, so therefore this is P is equal to tangent inverse of, okay, at point P you have x is equal to 5, y is equal to 2, so therefore this is 2 over 5. Okay, tangent inverse of the opposite 2 over 5, so y over x. Okay, so it's not the P that is negative 10. Okay, if you use negative 10, then for sure we will have an incorrect answer. Okay, so if we solve tangent inverse of 2 over 5, so we have here 21.8 degrees. Okay, so we will use that one in our next so we have 20 So a rho that, or it is cosine x, cosine p, which is 21.8. Okay, minus 10. Now ap dot ax. What is ap dot ax? So we know that this is a negative sign of 21.8. Why negative sign? So this follows the same as the previous. So we have here in the previous problem A, we got negative sign p. So the same explanation. Then az dot ax is 0. Okay. So then if you compute this one, we have the answer 22.3. So this is our ax. Okay. Now how about hy? So we have h dot ay that is equal to 20 a rho dot ay, not ax, okay, that minus 10 ap dot ay plus 3 az dot ay. Okay, so az dot ay is still 0 because they are orthogonal or 90 degrees or whatever the value of your z, it doesn't affect y. And that's the layman's term for that. So we have 20 a rho dot ay. So look at the drawing, a rho versus ay. Okay, now this is the angle, so this is sine. Okay, this is sine of 21.8. 21.8 again is from the point P. Minus 10 ap dot ay. So this is positives. Okay, so this is the angle here, so this is the ap, so the angle here below. Okay, so it means, okay, so the angle there is adjacent to ay. So adjacent is cosine of positive because it goes to the y direction. I mean the direction is the y. Okay, so you have this value. So if you compute this one, so we have hy is equal to negative 1.857. You can use your calculator to solve for this. So now how about hz? Okay, so you just multiply h with az. Now since there's no there's az there, okay, so you have actually the rest is 0 except okay, I'll just write a rho dot az minus 10 ap dot az plus 3 az dot az. Okay, so if you notice, the rest are 0 except the last term. So this one, az dot az, is like the same direction. This is equivalent to 1. Okay, so therefore h dot az is equivalent to 3. Okay, so our final answer is you have h. So therefore our final answer here for problem C is h with the vector 22.3, negative 1.857. And then okay, I will just rewrite this one to make it a bit clear. I'll transfer 3 to the other side here. This is equivalent to 3. So negative 857 and then for your gh, the magnitude of your g-axis is this one. Okay, so we're done with our problem number 6. So it's very important to know about that product, okay, and then also to understand how to get the ax.ap, ay.ap, and then ax.arrow, ay.arrow also. So you can check it out in some of the books. They will provide you the tables, but I don't want you to memorize that one. I want you to learn how to construct this diagram here below, okay, or here in this drawing. So once you understand that drawing, you can easily recall, is it positive sine p, is it cosine p, or is it cos, yeah, that's it. So so ax dot arrow, so that's it. So takes time, no, and we need to practice this type of problem. Okay, so our problem 7, so we're going to solve for the spherical coordinates. Okay, so I think that's it for now. Thank you.